Welcome back and welcome to Section 3, Functional Programming. Welcome to Video 1, Introduction to Functional Programming. In this video we're going to take a look at what functional programming is, pretty much a new way of thinking about designing and writing code, and some typical scenarios where it's going to help you. So what is functional programming? Well, as I mentioned, functional programming is really a totally different way to think about writing and structuring code. Up until now, almost everything we've seen and done has been something called imperative. Now, imperative programming is a little bit like a recipe for a cake. It's a series of instructions or commands that set out exactly how how you do something. We do this, we do that, and then if this happens, do something else, and then finally do some other thing. If you're making a cake or a cup of tea is a better example. Take the kettle, take it to the tap, open the tap, wait until it's suitably filled with water, close the tap, close the lid of the kettle, put the kettle on the power plate, turn the kettle on, go to the cupboard, open the cupboard door, etc. It's a very concrete list or recipe of an exact sequence of steps that must happen when your program executes. Now, functional programming is a completely different approach to this, and it's basically a different paradigm to writing code. It's not so much a series of steps, but more a description of what you want the outcome to be. So taking a Wikipedia definition, functional programming is a style of building the structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. It's a declarative programming paradigm, which means programming is done with expressions or declarations instead of with statements. Now, that probably sounds like a bit of a mouthful, and hopefully you're not too put off by that. So let's just break it down a little bit. Firstly, a sequence of mathematical functions. Essentially, the evaluation of functions against some data set. That's all that means. We evaluate a function against a point in a data set. Next, avoid changing state and mutating data. So that is, once we've assigned a value to a variable, we don't change it. And actually, you'll have noticed we've done this quite a few times already when we've used the final keyword on fields. And that's because I'm a strong believer in immutability in programming. As far as I'm concerned, once you set the value on a variable, we shouldn't change it unless we can really avoid it. It's better to create a new variable than to manipulate an existing one. And trust me when I say, from debugging large production systems, one of the most difficult things to do in a very large, complicated system is trying to keep track of the state of various variables. That is, if you've got your debugger open and you're trying to keep track of 10 or 12 different variables and watch how they change as you step over lines of code, it's really, really difficult. So if we can make our variables immutable, that is, so they don't change, trust me, your life is going to be much easier. It might not seem like a big deal now, but when we get to more complicated applications, it really does help. And lastly, from that statement, it's declarative. So that means we program by saying what we want to do rather than how we do it. So think about the differences between SQL, and hopefully you know SQL, where we do, in SQL we say select star from a table, whereas what we've seen so far is we've said x equals 4 times 10. So the declaration here, if we take a very abstract example like making a cup of tea, the imperative approach is we say take the kettle, put water in, turn the kettle on. The functional or declarative approach would be to say to apply the t function to water, and we know that the t function knows how to handle the water such that it gives us tea. So that's sort of the difference that we're talking about. Firstly, let's just sort of take a step back and get some context and understand a little bit of history about where this came from. So functional programming actually stems from something called lambda calculus, which was a mathematical system developed in the 1930s to express computation using functions. Now, initially this started out as a purely academic concept before slowly bleeding into commercial programming languages like Ruby, like Python, like JavaScript, and now as of Java 8, Java. As we'll see, a language doesn't have to be exclusively functional. It can actually combine elements of imperative and functional programming. And Java is a great example of this. It actually combines a number of paradigms. obviously we've seen that it's an object-oriented programming language. It's an imperative programming language predominantly, and now as of Java 8 and Java 9, it's functional as well, and we're going to see some really good examples of this. So let's take an example, a very simple practical example. Firstly, if we have a list of numbers stored in an array, and we saw in the previous section, we used this in several cases, in several examples, we've got a list of numbers stored in an array. In order to use this list of numbers in our application, we need to remove all elements that are not even, that is, which do not divide exactly by 2 without leaving a remainder. So we want to remove all odd elements, all odd numbers from this list. So let's think about how we would first approach this from an imperative point of view and then compare it with a functional implementation. And hopefully you'll get an idea of why people are starting to write code in a more functional way. So what we would need to do is actually implement a filter. What we want to do is filter out all non-even, that is odd numbers, from a list. So first of all, we need to create a new array that holds our even numbers, because what we're going to do is copy the even numbers out of our list of numbers. But firstly, actually, before we can do anything, we need to find out how long our array is. Then we need to create an iterator to go over every element in that array. Then we need to loop over each element in that array from 0 to length -1 and read each element. Now remember that in Java it's a 0 index language, so the first element in the list is always 0 and the last is always the length -1. So we need to loop over each element in the array from 0 to length -1, and we need to extract each element from that list as we go. And then for each element in that list, we must test if that element is even or odd, and if it's even, we need to copy it to the new array, and if it isn't, we skip it. So the code is going to be something like this. We have an array of integers that we want to filter, 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to create a new array of integers that will hold only the even integers, and then we want to loop over it. So for our iterator variable, int I equals 0, for I is less than the size of this array, increment I, and then for each index in this array, we want to get the value for it, so we read the element from the list. We want to use our, then we want to evaluate it against our filter function. So to do that, we use this modulo function. So the syntax for this reads like so. So value modulo 2 equals 0. So that's saying the value divided by 2 has a remainder of 0. If it does, it's even, otherwise it's odd. So the modulo operation is basically divides a number by another number and gives you the remainder. So if we divide the test value by 2 and the remainder is 0, we know that it's even. And if it is even, we append it to even array. So that's how we would take a list in Java in an imperative way. We would filter out all non-even values or all odd values. Now, if we want to do this in a functional way, it's much, much easier. Now, look how many lines of code that is and how hard it is to read versus this. We stream that list to a stream of variables and we simply apply a filter function to each value in that list. So you'll notice that this filter condition is exactly the same. Nothing has changed. And that's just put in place here. And that's sort of the beauty of functional programming. All of this stuff is boilerplate. Actually, the only piece of functionality that matters is our filter. Because if we were going to apply a different filter to test if the number was greater than 5, all of this code would be exactly the same except for this filter function here in the if condition. So essentially, functional programming wraps all of that up for you and allows you to express it as a function that you want to apply to your list. And that's all this is. It's a function that we apply to our list of values. We want to apply a filter function, and this is the expression criteria. This is the evaluation criteria that gets applied against each element. So why is it better? Well, take a look at both examples again. The imperative example is some 8 or 10 lines versus the functional example, which for all intents and purposes is 1 line. Which do you think is easier to read? If you saw this, you can see very quickly that we're applying a filter function to a list. With this example, it's not obvious that it's a filter. You need to read through each line to understand what's going on and perhaps even debug it yourself to figure out what's happening. This is very, very obvious what's going on. Functional programming doesn't necessarily result in better runtime performance, although it can. Under the hood, the compiler still has to do the same thing, and the JVM still has to execute essentially the same stuff. But what we get to write is so much more readable and so much faster to write, and therefore much easier to debug, and much easier to test, and of course in turn much easier to maintain. And because it's so much simpler, it's less easy to make mistakes. There's not a lot of room for mistakes in this code, whereas in this it would be very easy to make a simple mistake and the whole function would fail. Although this is a really simple example, imagine you had a very large and complex file that you wanted to transform. Perhaps you have many columns in that file and you want to transform it, you want to filter it, you want to do some slicing and dicing of the data. An imperative approach quickly becomes very complicated, whereas a functional approach does not. So let's just take a step back for a second. In the first approach, we're imperatively defining every event that needs to take place in order for us to achieve our task. So we go through and we write an exhaustive list of computational steps that need to happen in order to perform the task that we want. And we have to write code for each step we previously defined, from checking the length of the array to explicitly defining the loop, all the way through to checking if the values are even or odd, and then placing them in their output array. This is really verbose, and as we've seen, it results in a lot of code to achieve an extremely simple function, which is just to filter a list of values. Now, thinking about this the functional way, if we think about what we're trying to achieve, it's really simple actually. We just want to filter a list. We don't care about iterating over every element. We don't care about all the other stuff that goes on. All we want to do is filter a list. And that filter is a function that we want to apply to each element of our list. So the code simply defines the output we want to see, and the machine takes care of the rest, as opposed to writing a list of instructions the machine must take, or the computer must take. What we're doing is defining declaratively what we want the output to be. So this is known as a declarative approach, just like with SQL, where we define the output data set rather than the steps that are required to get to it. And notice that we don't have to create helper variables which might accidentally get mutated. So in the previous example, we essentially created a helper variable here, an even array, which we're mutating. So this is exactly what I said previously we would try and avoid. Whereas here, there's no mutation of data, there's no updating of arrays. All we do is we filter our list. So this doesn't get mutated at all, this stays the same. If we want to retrieve the value of this, we just collect it into a new list. And of course the result of this is much cleaner code. So a little comparison. With functional programming, we're defining the problem and the changes we'd like to see rather than an explicit imperative step-by-step approach. Now there's no state to manage, there's no array of even numbers that we have to mutate, no state at all. With the imperative approach, remember, we had to manage the state of our empty array. We had to make sure it started off as empty, we had to append values to it, we had to make sure it was of the right type. With functional programming, we don't have to do this, and we don't need to worry about the order of execution either. There's less use of loops in general and conditions, and these are replaced by built-in methods like filter that we've seen and recursion. So a last little bit of food for thought for this video, and then we'll wrap up. Imagine you're moving data from one system to another with lots of transformations and lots of processing. This is commonly known as an ETL, or extract, transform and load process. So say we've got an application database and a data warehouse. We want to move data from our application DB into our data warehouse. We're going to build something called an ETL pipeline, and it's going to extract data from the source system, do some transformations and processing on it, maybe some filters, and write the output into our data warehouse. Do you think it would be easier to do this imperatively, using loops and lots of conditions and state variables, or functionally? And which approach do you think would be easier to parallelize across multiple cores, or perhaps even multiple servers? Which paradigm do you think is more expressive for data processing and transformation? Now, I'm going to leave those thoughts with you.